Good morning, my dear students. Now, welcome to the video number 2 on GM counter. Okay. In this video, I'm going to discuss the gas-filled detector size. Here, what are detectors? They are nothing but nuclear detectors, and they're the special kind of detectors that can detect what? Alpha particle, beta particle, gamma particle, even that is low energetic X-rays also. Using these detectors, we can measure the energy of the particle, we can measure it. Not only energy, we can measure the momentum, we can measure it. Even we can measure the what? Direction of the particle also, we can determine it. Students, we have several types. Here, one is bubble chamber is there, scintillation detectors are there, gas field detectors are there. Here the gas field detectors are there. Now this is one class of detector, is one category of detector. Remember this. Gas field detectors are what? It is a one category or one set of what, one kind of what detectors. Now in this entire video, I am discussing the general, the principle, and also what the mechanism of the gas field detector. I am discussing the principle and also the mechanism of the gas field detector. By the end of this video, you'll understand what is the difference between what the proportional counter, GM counter, ionization counter, and all that. Anyway, for your syllabus, there is proportional counter is there, and also GM counter is there. Now I'm going to discuss with the ionization detector, or sometimes it is called as better to call it as a gas filled detector. That is gas filled detector. Okay. Here the gas field detector, you say, here, this one, this is the, here, cylinder that is. This cylinder is made up of what? Either copper, inner surface is made up of copper or something else. And at the center, there is a one wire is there. No, this is called as a water tungsten wire. That is very thin wire, hardly about 0.1 mm or something else. And here you see the end of this is what? Here it is insulated. Otherwise, what happens now? Since the body is what? Cathode, and this tungsten wire is anode, so that in order to prevent the from the contact, we are making the both are what? This one and this one is what? Insulated here. And here you see this one here. The tungsten wire is what? It is connected to what? This positive terminal of this via the resistance R. It is connected here. And next one is here the negative terminal of this battery is connected to the what? It is connected to the body of the cylinder. It is connected. Okay. Here there is a huge resistance is there. The value is near about in terms of mega ohm it is there. In terms of mega ohm is there. And here the voltage pulse will be developed across the resistance here, or signal will be appears here. This signal, it is in turn, it is fed to the other circuits like amplifier circuit. From the amplifier circuit, again the signals are fed to the what? Discriminator. And from the discriminator, it is fed to the what? The counter and all that. The purpose of the discriminator is what? To eliminate the signals due to the noise. Signals due to the noise effect, whatever it is that just we want to eliminate. These are the parts of the what? Parts of the gas filled detector. And inside this one, it is filled with what? Some suitable gas. It is what? Filled with some gases are filled here. That is, the gas may be what? Hydrogen gas, argon gas, or something. Is what? It is filled at a low pressure and all. This is about the construction part of it here. Okay, students. Here, remember, ionization produced by. Please now, before understanding this curve, that is, I'll tell you 1, 2, 3 points. There are 3 different particles. You know that alpha particle, beta particle, and what? Gamma particle. And also, you know that in the radioactivity chapter, alpha particle, that is what that is, but I will take this symbol. Alpha particles, the ionization made by the alpha particles are more. Next is less for the what? Beta particle. Next is less for the what? Gamma rays. Here three curves I have taken here. The three curves are there. They are this curve you see here. One is for the alpha, this is for the beta, and this is for the what? Gamma rays. Notice it here. For the same voltage you see, that is the voltage pulse is less for the gamma rays. The voltage pulse is more. That is 1 minute. One minute. Okay. Voltage pulse is here. For the gamma, it is less. Next, voltage pulse for the beta, it is what? More. Again, the voltage pulse for the what? Alpha is what? More, that is. That's why I told you, that is alpha particle, it produces a more ionization, beta particle less ionization, but whereas gamma particle produces the, still it is what? Less ionization here. Okay. Keeping this idea in your mind, now I'm going to discuss the different the reasons in this graph I'm going to discuss here. That is okay. Students, here the graph is plotted, that is number of particles, that is a logarithmic graph. It is here the number of particles, it is particles are detected by the what? Detector. Counts, you can say that, counts per minute or counts per second. This is along y-axis, whereas the voltage applied is across the what? X-axis. Voltage means this voltage, applied voltage. This is the, this voltage is very high, near about, we are going up to what? 2,500 to 3,000 volt and all that. This is the voltage supplied between the what? One is, this is anode, and this is what? Cathode and all that. Okay. Now let us begin this one by one then. Okay. What is this? This is the graph is plotted where? That is along y-axis what? The number of counts we plotted along y-axis, and the applied voltage is along x. Why? Because counts depends upon the applied voltage. Counts is the function of applied voltage. And also you know that y equal to what? F of x. You know that equation, y equal to f of x. Y is a function of x, but x is not a function of y. That's why counts are taken along what? The counts are taken along y-axis, and voltage is along what? X-axis and all that. Okay. Now, next. Now, first one is recombination reason here. This is the recombination reason, students. This part is called as a what? Recombination reason here. Here, what is recombination? I'll tell you this. In this reason, initially the voltage is very low. That is, voltage is very low. When the radiation enters the gas chamber, that is, as you know that it is what it produces here. Electron ion pairs are what produced here? Electron ion pairs are produced. Next. Next. Since it is applied voltage is too low, that is, the applied voltage is too low, so that ion pair cannot move towards the respective electrodes. Why they are not moving? Because they are not accelerated. Why they are not accelerated? Because there is no sufficient electrical field is there. Why there is no sufficient electrical field? Because applied voltage is what? Very, very low in this region here. Applied voltage is very low and all that. When the applied voltage is very low here, you see this part, I'm talking about this part. This part. This is the recombination reason. And this is the what? Recombination reason for the what? For the beta. This is the recombination reason for the what? Gamma radiations and all that. Next point, you see. Due to thermal motion, what happens is, when thermal motion, there is a recombination of positive ion and negative ions will be takes place. As a result, what happens is the neutral atoms are what? Formed here. That's why it is called as a what? Recombination reason and all that. But as it is applied voltage is increases, is, you see, I'm increasing the voltage here. As applied voltage is increases from here to here, then the magnitude of recombination will be decreases here. The magnitude of recombination will be decreases. But here, the acceleration of the electrons will be what? It will be increases and all that. Again, students, you see, remember, at this particular voltage, what happens is, at one particular voltage, what happens at this point, You see, the voltage pulse is more for alpha particle. This is more for the alpha particle. The voltage pulse is less for the what? Beta particle. The voltage pulse is still it is less for the what? Gamma particle. Why? Because alpha particle produces more ionization. That's why voltage pulse is more. But for the beta particles, the number of ionizations are less, so that voltage pulse is less. But still for the gamma particles, again there is the number of ionizations less, so that voltage pulse is also what? Less and all that. But one thing, just to assume that at this region, at this juncture, at this point here, dotted line and drawn, no, at this point, that you assume that almost there is no recombination. That is no recombination, and electron will be starts for what? Accelerating, because of what? Applied electric field. That is, we know that equation F equal to what? Q into E, and we know that equation mechanics Ma equal to what? Q into what? E. As electrical field increases, the acceleration is also what? Increases and all that. Now, beyond this reason here, then what happens is, that is, electron will starts for what? Accelerating. That is okay. Now, next one is ionization reason here. Ionization reason here. This one is ionization reason. This one, this part is ionization reason. Okay. Now let us begin in ionization region. What happens in the ionization region and all that. Yeah, you say again you are applying the what? Increasing the what? Voltage you are increasing here. Voltage you are increasing. One point you have to remember here students. In this region, what happens is here the almost it is flat here, sir. You see, this is almost it is flat region. Almost it is flat here, guys. Here the signal is there, no, that is whatever the counts are there, no, voltage pulse is independent of what? Applied voltage. It is depends on number of counts, it is almost independent of the what? Applied voltage. That point you have to remember. But still that is the voltage pulse is more for the what? Alpha particle, less for the beta particle, and still it is less for the what? Gamma particle. Remember, this is another ionization chamber. In this ionization chamber, what happens? That is, the number of counts is almost it is what? Same, that is constantly. Almost it is not exactly, it is almost it is what? Constant here. It is independent of what? It is independent of the applied voltage and all that. Now, here. When the applied voltage is sufficient, the probability of recombination decreases and it results into what? Output signal. Okay. Next. The signal strength is purely it is proportional to the particle energy. See, that is important point. Is that is signal strength is it is completely it is depends upon the what? The particle initial energy of the what? Particle here. Next, in this reason, signal produced is more for the what? Alpha particle compared to what? Beta and gamma particle and all that. Next. In this reason, basically it is used to measure the high energy particles here. Remember this point, this point. This reason is used basically for the what? It is used to measure the what? High energetic particles here. Because alpha particle has got more energy, that is. This is the distinguish between this reason and this reason. Later I will tell you what is the difference between ionization proportional reason and also what? In this reason. Proportional reason and this reason. In this reason, this is very important. This reason is basically used to measure the high energetic particle. This point you have to remember, and this point you have to remember. Here, it is independent of the what? Applied voltage. Next one is proportional counter reason here. Proportional counter reason. Okay. The word itself indicates that proportional means that it depends directly, proportional, and all that here. Here, as the applied voltage is increased further, the electron moves towards the what? Anode here. Electrons moves towards the anode. This is the proportional reason. So this part. And also you see in this graph, It is linearly, it is increases here, here. It is what? There is a linear relation is there. That means number of particles produced by the ionization, it is gone what? Increases with respect to what? With respect to what? Applied voltage. With respect to applied voltage, this is what increases the others. With respect to applied voltage, it increases. This is the, that's why it is called as a what? Proportional reason and all that. Understand here? Here, as a applied voltage increase, further electrons move towards the what? Anode. This is the first point. Next point. During the journey and the particle, what happens? They will make the several collisions. It makes here several collisions. The first, the it is what? That is electron of primary electron ion pair. Again, in turn, it creates what? Secondary. Next is what? Tertiary. In this fashion, that is what? The gas amplification or avalanche effect is produced here. What is avalanche? Avalanche effect, nothing but what it is? That is more number of what? The more and more number of what? That is positive ion and negative ion pairs are what? Formed here. This is next. In this reason, the voltage pulse produced is proportional to the what? The voltage pulse is produced proportional to the number of ion pair produced by the what? Radiation. This is the voltage pulse. The voltage pulse is more means number of ion pairs are what? More here. This will be increases with respect to what? Applied voltage and all that. Next. Next. This reason is used to detect and measure the energy of weakly ionizing radiations. This is important. This reason is used for the what? Weakly ionizing the radiation. That's why normally this reason we are using for the X-rays. That is X-rays. It is highly used for the what? X-ray. Low energetic X-rays particle. Low energetic X-rays particles can measure in this reason. Yeah, just notice it here. This point is important. This reason is used to detect and measure the energy of a weakly ionizing radiation such as beta and beta, gamma, and also what? Low energetic X-rays. Yeah, why it is called a proportional? Because it's a linear relation is there. Next, next counter is limited proportional. This is called as a limited proportional reason. In this limited proportional region, what happens is the linearity is going to destroy here. No linearity. At the end, what is happening is here, even if you increase the voltage here all the curves are meeting at this point only. That is, you see, curve for this one, that is curve for gamma rays, curve for gamma rays, curve for beta, curve for what? Alpha particle. It is all or what? Meeting here. And also, there is no linearity is there between, there is linearity between this curve, and this curve. That's why it is called as an what? Limited proportional reason. They will call it as a limited proportional reason. Now, see, as applied voltage is increased further, you won't increase the voltage applied further. Free electrons are accelerate towards the anode. Why there is, but all the positive ions takes a longer time to reach the what? Cathode. What is the meaning of it? Why there is a deviation from the linearity is, of course, more and more the electrons and ions of positive charge ions are produced. The electrons are the lighter particles. It will not take much time to reach the what? Anode. Whereas the positive ions are nothing but the heavy ions. It takes more time in order to reach the what? Respective electrode and all that. As a result, what happens is there is a more and more accumulation of the what? Accumulation of the what? Collection of the charges around the what? Anode will be takes place here. That's why what happens is it is the linearity. It will go into what? Destroy. Next one here. Let's say due to high concentration of the positive ions around the diode, there is a distortion in the what? Gas amplification. Don't think that it will increases. Gas amplification will be what? Decreases, which results into what? Non-linearity. That's why you see all will be meet at the same point. Though their ionization power of alpha is different, beta is different, gamma is different, but all will be meet at the same point. Next. Here, applied voltage is so high that even single low energetic electron creates the avalanche effect in the entire length of the chamber. That is here. The avalanche effect is produced by all electrons. That is, suppose one radiation enters into it here. That is 100 primary electrons are there. All 100 primary electrons are responsible to produce the what? The avalanche effect. That's why you see here. That's why here the the count is what? More here. That is, the voltage pulse is what? It is more in this reason here. This point is important. Here, all primary electrons leads to what? Avalanche effect here. Next. Oh, this is very, very important one. That is Geiger counter. That is, we can discuss in the GM counter also here. Okay. Geiger Muller counter. Here in the Geiger Muller counter now, it comes in one. This will be comes here. That is in this reason. Here the curve is almost, it is flat here. That is almost, it is flat. That is, theoretically it should be flat here. That is. Here, you see, now ionization current becomes independent of the applied voltage. Okay, you see, it is same. Ionization current is same, even though you are increasing the voltage, you are increasing here, but the curve is what? Flat here. The number of particles detected by the chamber, it is or produced is almost, it is what? Constant. Next, here another big thing is, I'll discuss it now. It cannot able to distinguish between the low energetic particle or high energetic particle. You cannot distinguish whether this pulse or this count, whatever the voltage pulse is obtained, either due to the alpha particle or beta particle or gamma particle. But however, GM counter, it counts. GM counter, it counts. GM counter works in this Plateau region. This, whatever the reason I told you, no, this is called as a what? Plateau region. Here, but it is good, to count. We can measure the counts, we can measure it. And one more point, of course, I've not written here. The efficiency of the GM counter is very, very high in this region. Don't forget to this point here. Why people are working in this region is GM counter. Here, the efficiency of the counter is what? Is maximum here, that is in the flat region. This flat region, sometimes we call this what? Plateau region also. And another point is what? The important demerit of this is what? That comes under demerit. The GM counter is unable to distinguish what kind of radioactive radiations enter into the what chamber. Whether is it alpha particle is entered, or whether this count is due to beta particle, or whether this count is due to what? Gamma particle. We cannot say it. This is the, and another point is what? The efficiency of this counter is what? Very high in this region here. Next one is discharge region here. Students, this is the discharge region. It is unsafe. If we increase the voltage beyond this, if we increase it now, if we increase the voltage beyond this region here, this is called as what? Discharge region. It is more dangerous one. Here, your tube may going to what? Destroying all that. And also that is, even in the absence of the radiations, though the radiations are not entering into the chamber, even then, the counter will be shows the what? Readings it will show this. Even in the absence of radiations also, think that there is no radiations. Even then, that is what happens is counter it will show the many readings it will show. And it is all avalanche effect. Further increase in voltage beyond the Plateau region leads to discharge of the gas, even in the absence of what? Nuclear particle entering into the chamber. This point is very, very important. Okay. Right. Another point is what here now? To be on safer side, it is not to operate the GM2 in this case. Otherwise, the two may go into what? Destroy and all that. Okay. Normally, it is about to 1,500 or so. There is, I think, probably the 1,250 and all that will not go for the in the GM counter. Okay. This is another important 3-4 points are important here. That is, I am recapitulating the things, but of course, I discussed in the previous video also discussed here. What is quenching? It is a popularly asking the question. The quenching means the process of what? The process of removal of all positive ions which are surrounded by the what? Anode. And detector is making it ready to record the what? Fresh event is called the what? Quenching. Here, what happens is in particular reason, what happens is where the more and more the positive ions are surrounded around the anode. Already explained here. The positive ions are what? Heavy particles. It takes more time in order to reach the what? Cathode. So that as a result, more positive ions are surrounded by the anode, so that potential difference into what? Decreases. During this event, what happens is your counter is unable to sense, or your counter is unable to detect any particle enters into the what? Chamber, either alpha or beta or gamma particle. So that it is better to what? Prepare the counter to detect the what? The fresh radiations. For that, what you have to do is you have to remove all the positive ions. You have to remove it. Just like how you are cleaning your room and all that. It is like you have to remove all the positive ions which are surrounded around the what? Anode and all that. That process is called as what? Quenching effect. Of course, this quenching method is achieved by one is external quenching, and another one is what? Internal quenching. In internal quenching, where we're adding along with the argon some either bromine gas or else what? Any alcoholic compound, ethyl alcohol were added. This is the purpose why people are adding. There is what? Methyl alcohol and or ethyl alcohol or bromine along with argon gas is what? To create the what? Quenching effect. Next, one more terms are there. Merits and demerits of GM counter. The merits, of course, all these things I discussed here. The demerits I told you. What are the demerits? It means we cannot distinguish between the high energetic and low energetic particles. We cannot distinguish here. It can be used only for the what? Low counting rate, but not for the high counting rate. It cannot detect uncharged particles like neutron. Of course, it is not so correct because some other indirect methods are there by which also you can measure it. Next is it has low efficiency for the gamma radiations and also low efficiency for the beta particles. And one more parameter is here, recovery time and dead time. That is also important. What is dead time? Dead time means it is the time during which your counter is unable to sense, unable to detect any radiations. That is called as a what? Dead time here. And what is recovery time? It is the time required to prepare your counter to detect the what? The fresh radiations. That is called as what? Recovery. The word itself is indicates you are preparing the counter to detect the what? Any fresh events. That is called as what? Recovery time. But here, dead time is hardly about 100 to 200 microseconds is there. Say it is 100 microseconds is there. Recovery time is what? 50 microseconds is there. Then 100 plus 50 equal to what? 150 microsecond. This time we call it as a what? Paralyzed time. It is called as in what? Paralyzed time and all that. Students, remember, many that is out of all this here, the GM counter is important and also what? The proportional counter. In the proportional counter and the GM counter, that is in case of proportional counter, what happens is each radiations, each radiation, suppose one alpha radiation, and this is also what? Another alpha radiation. Here, each this one will produces the what? Many primary electrons produces here, that is primary electron. This also produces the what? One is primary electron will be, and another one is positive ion is produced here. This each electron is there now. It is responsible for the what? It is responsible for the what? Avalanche effect here. Whatever the primary electrons are produced now, all primary electrons are responsible for the what? Responsible for the avalanche effect. As a result, what happens is that is voltage pulse will be what? Increased. This is the beauty of what? The proportional counter. Now, with this idea, now I will end up my session. Thank you. One and all.